Routing and Remote Access, Part 1. Well, I'll tell you, Microsoft's real proud of their routing and remote access server, and so proud of it, in fact, that there's a lot to talk about with this topic. So this is going to be just part 1 of many parts relating to routing and remote access. First, we'll look at some of the basic functions of routing and remote access, see the kinds of things that it can do. You can use it for VPN, for dial-up, demand dial, all different kinds of things. And then we'll look at how to configure it using the routing and remote access setup wizard. Now, the wizard's really the way to go, especially if you have only a single purpose for the routing and remote access server. But once you've used the wizard once, you're burnt. You can't use it again, so you have to do everything else manually there. Then we'll look at DHCP Relay Agent, which we've already covered in a previous nugget, but we'll briefly refresh our memory on that part. And we'll look at the server properties. We need to know especially what the authentication protocols are. Those are crucial for compatibility with older clients and for making sure that you can establish an authenticated connection. You need to know which ones provide mutual authentication, encryption, all kinds of stuff there. And we'll look at IP address allocation as well, whether or not you want to use a DHCP server or static addresses, as well as point-to-point protocol items on the server properties. And then finally, we'll take a look at how to log routing and remote access services. Now, before we get too involved with routing and remote access, let me just point out that I have never seen a service in any Windows operating system that has more dialog boxes, radio buttons, check boxes, drop-down lists, configurable items. There's got to be hundreds of different things to choose from. However, only probably, 10% of them are actually used for common functions that most administrators would need. Some of the rest of them are for obscure vendor-specific configurations. However, for routing and remote access, or RRAS, or just RAS as I usually call it, we'll just go ahead and take a look at the basic functionality of it. Here I just want to point out what RRAS does for you and what you can use it for. And then after this, we'll go ahead and start configuring it for various purposes. First of all, you can use it for dial-up, just like normal dial-up connections so that a remote user can dial into your network. You can also use it for demand dial connections. That might be a small branch office that needs to make a connection to the main office, and they don't want to have a 256K ISDN line on all the time, especially if they're charged for usage. Well, as soon as someone tries to use it, RRAS will immediately just make it hot and turn it on. And then you can also use VPN with the routing and remote access. Virtual private networks allow you to have private traffic over a public network such as the internet. And then we'll also use it for routing purposes, and it does support RIP and RIP version 2 and OSPF, or Open Shortest Path First routing protocol. Now, it's extremely unlikely that unless you're on a very shoestring budget and you can't buy real hardware routers like a Cisco router, it's very unlikely that you can use Microsoft's routing function. In fact, let me just point out here that much of this, in fact, if not all of this, is not very often used by many major corporations. Now, there are some that will use RRAS for their dial-up or VPN connections or their IAS connections, but otherwise, just frankly, most of the time you're using third-party solutions, such as Checkpoint firewalls or Checkpoint VPN or some other vendors' VPNs. But nevertheless, these things are all available, and they do work. Now, network address translation is what's going to allow us to use a private IP address internally and then use a shared public IP address externally on the internet and allow us to have that internet access in a protected way. And we can use DHCP Relay Agent, which we talked about in our DHCP section earlier in this whole series, and we'll quickly review that as well as the Internet Authentication Service to consolidate the accounting as well as the logs for routing and remote access. So you might have multiple RAS servers out there, and you can kind of consolidate the authentication and logging into a single IAS server. Or you might also know this as a radius server, because other vendors call it radius, and we'll kind of use these terms interchangeably. Now then, when it comes to actually configuring routing and remote access, first of all, be aware of the fact that it's probably not best to set that up on a domain controller, because a lot of times an RRAS server is going to be a border router. It's going to be directly connected to the internet, processing traffic on behalf of your private network clients. And if it ever gets compromised on the internet, well, then someone's directly gotten into your domain controller, which should be the most protected server you have in your environment. So, not usually a good idea. And for that purpose, I've gone to DC Nugget 1 here, and I've run DC Promo to demote it as a domain controller, and now I only have DC Nugget 2 as a domain controller, and I've just added in all programs here in the administrative tools, I've just added in adminpack.msi so that I can still manage all those same things from here, like Active Directory users and computers and the like. Now, let's go ahead and go to routing and remote access. It's really on the Start menu by default already. You don't have to add it through add remove programs like we've done in previous versions of Windows. And all you really need to do now is to right-click on it and choose Configure and enable routing and remote access. Sounds easy, right? Well, really, the wizard is pretty easy. You just click on this right here, and that's the only way you can do this. You have to use the wizard. And once you click on it to start the wizard, you specify what kind of a configuration you want to have. For example, if I were to choose a remote access dial-up or VPN, it would take me through the necessary steps, ask me if I wanted to use packet filters, which we'll talk about a little bit later on. That'll automatically set up 128 PPTP connections as well as 128 L2TP connections and so forth. For our purposes, and you see several of the other choices that are here as well, for our purpose, I'm just going to do a custom configuration because that gives me the most minimal configuration. That way I can show you how to add things in later on if you want, because once you've used this wizard once, you can't use it again. So if I originally had this as a dial-up or VPN server, and later on I also wanted to make it a router to give myself a secure connection between a couple of offices, well, I couldn't do that anymore using the wizard. I'd have to configure it manually. So that's why I'm going to choose the custom configuration. And when you do that, you have to choose something. So I'm just going to choose VPN and dial-up. How about that? And then we'll go ahead and click on Next, and I'll show you how to add in additional features if you need them. Then that's pretty much it for this wizard. You just click Next and Finish, and then it needs to start the service. And here it asks if you want to start it. Of course we do, so I'll go ahead and click on Yes, and after a few moments, it'll start up, and we'll be ready to go. Now also here it's already started up now. Now let me also point out that although the wizard allowed me to choose dial-up and VPN as one of the configurable options, I chose it manually and it did not give me as many options. It basically just allowed me to turn on that functionality. If you choose the wizard to do those things for you, then it also asks you for port filtering and stuff like that. Now using dial-up connections and VPN, if I go to ports, I see that I've got my VPN connections here, which like I said, there's 128 PPTP, 128 L2TP already added in here for me. And then let's go ahead and take a look at what else we have here as well. If we did have anybody connected through a dial-up or VPN connection, they would show up here. We could reset that connection. We could send them a message or whatever else we wanted to do with any of those connections that were here. Under the IP routing item right here, if we go to General, we see that we have network cards that are dedicated here. For example, here I've got Public Network. This was originally Local Area Connection 2. This one was originally Local Area Connection 1, actually the first one that was installed with Windows Server 2003 when it detected my network card. So I do have two network cards in this machine. I just renamed them to make them more intuitive for later on when I make this a VPN connection so that you can identify the difference between which network card is connected to the public and private network. And also notice that the private network has a private IP address and the public network item has a public IP address. Later on, we'll be looking at routes, and here's a list of static routes, of which there are none right now. We'll see what the importance is of a static route, how to configure those from both a command line as well as within this interface. Now, I mentioned the DHCP relay agent in a previous nugget. In reality, the DHCP relay agent is always installed by default whenever you enable routing and remote access. But if for some reason somebody deleted it here and it was gone, and they made a mistake, then to get it back, you simply right-click on General, and then you choose routing protocol is what we're looking for here, and then look for DHCP relay agent, and OK, and then you're back in business again. You got it right back here, and then you'd have to select the interface that you wanted to use for it, public network, private network, whichever one you wanted to use. And then you'd be ready to go. Then we looked at this in a previous nugget as well. This simply allows us to relay the DHCP packets. Have to make sure that that is selected. Now remember, the DHCP relay agent allows hosts on one network that are doing DHCP discover broadcasts to traverse across this router and allows us to forward those DHCP discover packets onto a DHCP server on a different segment. Because otherwise, this router will just block that broadcast and not allow that broadcast to pass through. Therefore, those hosts on the first segment would never actually get an IP address because the DHCP server would never hear the broadcast. And then there's a hop count threshold, which means it'll go across a maximum of 4 hops or 4 routers. And then there's a boot threshold here as well in seconds. And this means that if it doesn't hear an answer on its own segment within 4 seconds, then it'll go ahead and pass it on. And of course, you can adjust these numbers as necessary. And then the remote access policies we'll be covering in more detail later on. These are crucial to successful connections with RRAS. I mean, these are the crux of whether or not a connection actually takes place, and we'll look at the importance of that a little bit later on. And then you can specify how you want the remote access logging to take place, specify a log file or a SQL server if you like. This is, of course, going to be a better option if you have quite a lot of traffic going on here and you have a SQL server available. Or if you are running IIS server as your radius server and you want to centralize the database, then of course you'll probably use a SQL server there as well because it'll be easier to manipulate the data. Now let's go back up to the properties of the server, and here we're just going to right-click and choose properties. And by the way, you can see from this also, you could disable routing and remote access if you wanted to start over from scratch for some reason. Let's also go ahead and go to all tasks. From here we could stop, pause, or restart the service. Pause, of course, would allow your existing connections to continue on, but it would not accept new connections. Stop just does that, just stops the connections you already have and stops the service from accepting new ones. And then we could, of course, restart it. And then let's go down here to the properties. If we go to the properties, we see that on the General tab, by default, this will be configured as a router using the options I already selected. Now again, because of the handy little wizard that I used early on in this, it automatically selects some of these options for me. But if you are not able to properly route through this server, make sure that somebody hasn't gone through here and cleared this off. Or if they have selected it, that if you've got domain dial connections, someone hasn't selected this item instead. And so again, a lot of the troubleshooting related to RRAS really relates to making sure that the right-click item is done here. We can also make sure that the remote access server is enabled by selecting this checkbox. This will allow us, of course, to receive our modem dial-up connections as well as our VPN connections. And then on the security tab, we have some critical items here relating to whether or not we're going to use IAS, or Internet Authentication Service. The authentication provider right now is Windows Authentication. If this is a standalone server, standalone RAS server, then it's going to use Windows Authentication against a local SAM database of user accounts. And when someone makes a VPN or a dial-up connection, for example, then they have to enter in the credentials from that local database. If it's an Active Directory system, it's a member of a domain like this server is. Right now it's a member server. Then the Windows Authentication they have to enter in would be a domain user account. And then for authentication methods that we select here, we have a variety of different security options we can choose from. Now, of course, when someone dials in or makes a connection attempt to this routing and remote access server, the job of our RRAS is to make sure that whoever's trying to access me is authenticated to do so, and they have the proper credentials. Well, you can do that a number of different ways, and this is a critical dialog box to understand. Some of these things will also appear in other places within RRAS, but you need to understand the difference between all of these and where each one of them might best be used. For example, let's take a look first of all at the Extensible Authentication Protocol. This is kind of an open-ended protocol that allows you to use additional authentication methods. So, for example, if you decide to use Extensible Authentication Protocol, then your available methods would be whatever appears when I click on this button, which would be MD5 Challenge or Message Digest 5 Challenge, which would involve a hashing algorithm. Protected Extensible Authentication Protocol, which really goes more towards wireless connections. And by the way, you can use router and remote access for wireless issues as well. We don't really cover that as much here as we do in other nuggets, but that is another possibility for it. And this will help to build a protected Extensible Authentication Protocol kind of a channel that will then allow whatever Extensible Authentication Protocol methods you're using to go ahead and pass through securely. Then you can also use a smart card or other certificate you see here as well. Oh, by the way, let me also go back up to this MD5 challenge. Well, when would you use that? You'd use that if you were working with other clients besides Microsoft clients that did support MD5 challenge. It's really it's just a different version of CHAP, which I'll talk about shortly here. And it does support encryption of the authentication data. In other words, your username and password will be encrypted. But the actual data that's sent back and forth on the wire, besides the authentication data, that stuff is not encrypted. So just be aware of that. Now, we'll explain the MS CHAP version 2, and then MS CHAP here, which is really version 1, and then CHAP down here. It's best if I start with the weakest of these, which is CHAP, and work my way up. With CHAP, it's an MD5 hashing scheme, and you encrypt it encrypts the password. Now, if someone is able to pick up on the encryption key over the wire, and this will be possible, or the encryption hash, then they can immediately reverse engineer to determine what the password actually is by easy brute force methods. And there's a lot of hackers tools out there that have already exploited this. This is exploited and cracked like probably on a daily basis. So you try not to use CHAP if you don't have to. And this is really only good for backwards compatibility with other clients that are non-Windows clients or with very old Windows clients. Also, when you do this, you have to be able to store the password using reversible encryption. You can do that one of two ways. For local accounts, you could just go to the user account and select the option on their account properties that says store password using reversible encryption. Or you could do the same option in a group policy if it was in a domain. But that means then that whatever the database, whether it's the SAM or Active Directory, it stores the database password or that user's password reversible encryption. So it's going to be very easy to crack. Also, if someone's password changes when they try to log on, with CHAP, they will not be able to change that password once they get that message that says it's time to change your password. They have to log on to the LAN first and change their password, and then they can continue to use CHAP thereafter. Also, CHAP will only encrypt the actual authentication. Again, it's reversible encryption, so it's easy to crack. And it does not encrypt the actual connection data itself. Now, MS CHAP version 1 is a much stronger method of encryption and challenge than the original CHAP is down here. With this one, the authenticator, that being the RRAS server or the IAS server, will send a challenge to the RRAS client, and that will consist of an arbitrary challenge string and a session identifier. Then the client will send back a response, and that's going to contain the user's username and a non-reversible encryption of the challenge string. So we're using non-reversible encryption here now, which of course would be a good thing. So it's non-reversible encryption of the challenge string, the session identifier, and the password. Now, the authenticator will then check to see if the user's credentials are authentic, and if they are, of course, the user gains access. Well, if you use MS CHAP, like we're showing here, then you can also use Microsoft's point-to-point encryption to encrypt data over a PPTP connection, or a virtual private network using point-to-point tunneling protocol. Now, one other thing to keep in mind if you're using version 1 right here is that you cannot use a password that's any larger than 14 characters, and that's going to be kind of critical, especially for highly secure organizations that require more than that. Now, even though MS CHAP version 1 here is better than CHAP, it still has some weaknesses. For example, it still allows backwards compatibility with LAN manager encoding, and that's cryptographically weak, and so that's not so good. But MS CHAP version 2 no longer allows LAN manager encoded responses. Also, MS CHAP here is only one-way authentication, so the server can be sure that the client is who they say they are if they log on properly, but there's no way for the client to make sure that the server is who they say they are. So the client could be logging on to a bogus server or to somebody who's trying to intercept credentials, whereas MS CHAP version 2 does provide two-way authentication, also known as mutual authentication. Also, with this MS CHAP down here, there's a 40-bit encryption cryptographic key that's based on the user's password. And each time the user connects using that same password, it generates the same cryptographic key. So it's easy to watch for patterns on the network and to be able to determine what the password is eventually. Whereas with MS CHAP version 2, it still uses a cryptographic key based on the user's password, but it adds that arbitrary challenge string to the cryptographic key there, or to the cryptographic material. So each time the user connects, even using the same password, a different cryptographic key is going to be generated. It's going to make it much more difficult to guess the password, or to reverse engineer the password. And then finally, MS CHAP does encrypt data sent on the wire, but it uses a single key for both directions, sending and receiving, whereas MS CHAP version 2 uses separate cryptographic keys for sending and receiving data. Now, there's still some compatibility issues to keep in mind here as well with MS CHAP version 2. First of all, it does not work with Windows 95 until after you've installed Windows Dial-Up Networking version 1.3 on Windows 95. After that, then you can use MS CHAP version 2 for PPTP, virtual private network connections. But it will still not work for dial-up connections on Windows 95. Oh, and also for both CHAP version 1 and 2 here, by the way, if your password expires and you need to change it during your dial-up connection or your VPN connection or whatever you're using to connect here to the RRAS server, it will allow you to change the password using one of these authentication methods. Now let's get into the scary stuff. Down here we've got SPAP, which is the Shiva Password Authentication Protocol. Uses reversible encryption, which hackers have been able to, in the past, pick off the wire and then use it in replay attacks so that they will also authenticate against the same server without even learning the password. They'll just send back the same encryption key that was used originally, and then the RRAS server will decrypt it and authenticate that hacker. So that's kind of scary. Also with SPAP here, you cannot change passwords during authentication if your password's expired or anything like that. And you cannot use it with virtual private networks because it does not support Microsoft's point-to-point encryption, or MPPE, which is a crucial component of PPTP, or point-to-point tunneling protocol, for VPNs. And then finally we're down to just a completely unencrypted password. So this password here will be sent across the network in the clear, and any packet sniffer will be able to find the password, just like we've seen in the past with FTP passwords. Really, the only reason why you would want to use this is just for testing purposes, just to see if you can rule out authentication as the problem and see if you can still connect using the remaining methods that you have in your remote access policy and so forth. That would pretty much be the same as allowing systems to connect without authentication at all, just about, which explains itself. Now let's review some things here just real quick, and we're also going to use this in kind of a pop quiz format. So I'm going to ask you some questions and see if you just happen to know the answer in your head. If you don't, that's all right, because there's a lot involved with these authentication methods, and I haven't addressed every detail yet. I'm going to do that in the answers for some of these questions. Now first of all, if I want to use a smart card or a certificate, what method will I use? Well, remember, it has to be the extensible authentication protocol, because that's one of the methods you can use, smart card or other certificate. By the way, keep in mind that if you don't know exactly which systems the users are going to log on from, maybe they're in a factory warehouse where the managers can roam around to any one of 100 computers, and there are 300 different managers and supervisors and so forth that could log on there. Well, if you were to put a certificate on each one of those systems for each one of the managers, you'd have to put on 30,000 certificates total. That's a little bit impractical. So what would be a better solution would probably be to use a smart card, because they will carry around the credential, or at least the certificate, on the smart card with them. Then remember that you can also use PEEP for wireless or MD5 challenge as well. Now, again, going back to our warehouse situation, if it's not practical for those supervisors and managers to have smart cards for some reason, then you could go to MS Chat version 2, which is still an excellent protocol. Now, let me ask you another question. Which one of these methods supports encryption of the data? Well, actually the top three that are already selected. So the default options all support encryption of the data. EAP, all the methods there. MS Chat version 2 and MS Chat. All the rest of these do not encrypt the data. However, what do they encrypt? Well, they all encrypt the authentication down to the point where you get to SPAP. But remember, SPAP is reversible and very easy to crack, or easy to replay at least. And then an unencrypted password, of course, doesn't encrypt because it says so right there. And then without authentication, of course, would not either. And then finally, with mutual authentication, remember, normally you will think of encryption, rather of authentication taking place from the client to the server, so that the server authenticates whoever's typing in their username and password. But remember, we also want to authenticate the server, because somebody could be setting up a fake server or an impersonator and snatching out passwords and credentials. So what we want to do is to understand which one of these supports mutual authentication. And for that, only your top two methods will, EAP as well as MS Chat version 2. Now let me also point out in this dialog box that if you decide to use Internet Authentication Servers, which is just Microsoft's implementation of a RADIUS server, which stands for Remote Access Dial-In User Service, then you can choose whichever RADIUS server or IAS server you want to use from here. You simply select the authentication provider from this list, choose RADIUS Authentication, and then configure that, as well as with the accounting provider, so that you can keep the logs either on the local system with Windows accounting or RADIUS accounting to centralize it all. Now, let me go ahead and address a little bit more about what RADIUS actually is and IAS actually is for the time being, and then we'll get into a little bit more detail when I actually show you how to configure an IAS server later on. But for now, let me just explain a little bit about what it is so we have some context as we go. We have laptop users coming in here through a VPN or a dial-in connection, doesn't really matter, and they're connecting to RAS servers that we see here. Now, before we actually implement a RADIUS server, what did each one of these RAS servers do if they're member servers? Well, each one separately connects to the domain controller, wherever it is, and they authenticate the user's credentials that are trying to dial in or VPN in. Now, that's okay, except that I might have this server in Los Angeles, this one in Miami, this one in Denver, and I, as an administrator, then have to administer each one of them separately in terms of their authentication and all of that. And if I expand that out like I'm an ISP and I've got dozens or even hundreds of RAS servers throughout the world that I'm trying to manage here, then anytime I have a change in the authentication protocol I want to configure for my company's standard, well, now I got to do it on all of these things. Well, that's where RADIUS comes in. Because with RADIUS, what I can do is to configure all of my RAS servers to connect to my RADIUS server, and then I configure my authentication settings and a lot of other settings as well centrally on this IAS server instead, and then I only have to configure it here. Plus, the other thing that happens then is that now when these RAS servers connect, they become RAS clients, or actually RADIUS clients. and this is the RRAS server, of course. So when you see the term RRAS clients or IAS client, don't think of these laptops out here like we're used to thinking of clients. The client is actually a server. It's a RRAS server that says, hey, I've got credentials from this laptop user. I need to check them out against a domain controller, but I don't do that myself. I just simply pass them on up to the RRAS server. And then the RRAS server collects all the credentials from whoever's its RRAS servers are, and passes them on to the domain controller, which then does the authentication, which it passes back to the IAS server, and then the IAS server says, okay, that person's good, allow them to log on. Now that looks kind of involved, but actually it's very fast, and it's actually very efficient as well, because, especially in terms of your administrative responsibilities, you're centralizing your administration here to an IAS server, and you're centralizing your logging as well. That way I don't have to chase down each one of maybe dozens or even hundreds of RRAS servers and checking out each one of their logs individually. No, instead I just check it out on a single IAS server. And you might have more than one IAS or RRAS server in this mix, but generally speaking, you're just consolidating it more so that you have fewer RRAS servers than you would have had for RRAS servers. And then I need to configure the RRAS server, so I click Configure here, and I'll add in my first RRAS server by clicking on Add, and of course I can have multiple RRAS servers in this list if I need to, and I'll just click on Add here and enter in the RRAS server name. RRAS 1 maybe, and then I'll have a secret. Now the secret will be on both this remote access server as well as on the RRAS server, and they'll have to share the same secret password. So I'll click on Change here, enter in a long complex password. Microsoft recommends 22 characters, alphanumeric, upper lowercase, special character, so make it a tough password in other words. Then we'll enter in a timeout in seconds, which relates to whether or not it connects to additional RRAS servers. So if I've got RRAS 1 and RRAS 2 as well, and it can't connect to RRAS 1 after 5 seconds, then it will fail over and try to connect to RRAS 2 instead. The initial score starts at 30. You don't usually need to adjust this manually, but this will adjust itself automatically the longer the RRAS server is online. The server that's most responsive and that handles network traffic the fastest will get a higher score, and it will be able to handle more additional requests. So those scores will fluctuate from time to time. Then there's also a port number here. TCP port 1812 is what your authentication takes place over, and your logging takes place over port 1813, so keep that in mind. And again, you can use a message authenticator here to make sure that the RRAS server is who it says it is, as well as the RRAS server here. And then again, you'll have multiple in this list if necessary. And then for the accounting provider, if you're also going to use RRAS for the accounting, which again is a great way to centralize all of the accounting so you don't have to chase down different servers, click Configure and you see all the same options here, except that the port number is 1813 instead of 1812 here for accounting. Now, of course, you can change that, and that's why it gives you the opportunity to do so in this interface. And then this checkbox here, send RRAS accounting on and accounting off messages. This relates to when the RRAS server starts up, and when the service starts up, it turns on accounting. When it shuts down, it turns off accounting. And then back in here, we have the allow custom IPsec policy for L2TP connection. We addressed that in a previous nugget. But here we would just enter in a pre-shared key. Not the most secure method for doing this, of course. This is really best for connection attempts where you're just testing things out. I just want to see if I can establish an L2TP connection, and if I can, but I'm having other troubles with my normal L2TP connections, then maybe it's some other issue is causing the problem. Now from the IP tab here, we see that we do enable IP routing, and it allows remote access and demand dial connections by default. But what we really want to look at here is the IP address assignment, where we see that by default it uses DHCP to obtain an IP address. And how exactly does that work? You see, when the client dials in, let's just say it's through a VPN connection. When that client connects to this server, if it can't get an IP address, it's going to get a 169.254.x.x address. That's an APIPA address that we looked at way earlier in this series. Now, if there's a DHCP server available, that VPN client does not broadcast for a DHCP address directly to that DHCP server. Instead, what happens here is that this RRAS server, this routing remote access server, is what broadcasts for a DHCP address. And let's take a look at what happens there, where I go to DC Nugget 2, where I've already configured DHCP services. And that's where I moved it away from DC Nugget 1 here. I moved it onto this server. Now, in my address pool, let's first of all go there. I've let out 10.10.10.20 through 254. When it attempted to lease those out to the RAS server, some of these were already taken, and it has IP conflict detection enabled, so it detected that these were bad addresses that it wasn't going to give out. So it gave out the next 10 addresses, and if you count them, you'll see that there are 10 addresses available here. And that's exactly how this works with RAS servers. RAS servers will send out a broadcast, DHCP Discover broadcast, looking for a DHCP server, and then here I've captured and filtered for all the DHCP traffic that goes on with that. You see that it went from this local RAS server in a DHCP Discover packet. It got an offer back from the server, which is its IP address is on DC Nugget 2 over there. And then it requested to keep that address, and then DC Nugget 2 acknowledged and allowed it to keep that IP address, which if we go down here and look at it, was the first one it was 10.10.10.23. And then it goes through all 10 of these. It goes from that one and it goes on to the next one, and it got an IP address thereof, 10.10.10.24, and so on and so forth until we get our first 10 leased out from that DHCP server. Now let me also point out that Microsoft documentation pretty clearly states that if you're going to use this option, you need to also configure the DHCP relay agent. But if I go to a command prompt, notice that I'm on the 10.10.10.class C network here. Well, my DHCP server is also on the same segment right there, and as long as this RAS server has an interface on the same segment as the DHCP server, there's of course no need to configure the DHCP relay agent because I don't have to go across a hop to a different network to get to that DHCP relay agent or to the DHCP server. However, I will also point something else out with this, and for that let's go to the actual DHCP server itself where I've got a remote desktop connection. And then here's the actual 10 addresses that it actually leased out. Now, what I want to get to here is look how long the lease duration is for. This is March, I think it's the 30th, and so that's a week long at least. That is the default value that you have when you first configure a address lease range or a scope by default. Well, that might not be to the best of my allocation for IP addresses. Now, I'm on a 10 dot here that I'm pretty flexible with. But if I'm in a scenario where I'm in a small environment where I've only got a limited number of addresses to be able to use, and I've got to really conserve those, I might not want to lease out 10 addresses at a time and then have them leased out for a whole week and not be able to use them for anybody else. For example, if I'm in a small office here, and during the day I have clients that lease out their addresses, I don't want them to lease out addresses on a normal 7-day duration. However, at night, on the other side of the globe, I have users that VPN in from a different continent in a totally different time zone when no one's on the network. Well, when they dial in, I don't want them to deplete all of my available addresses from the DHCP server, so I might just configure them with maybe an hour lease duration for these RAS servers. Well, how am I going to do that? How am I going to configure a scope up with a 7-day duration for some clients, but only a 1-hour duration for others? Well, see, there's a little-known scope option that you can configure for that. And for that, I'll right-click here and choose Configure Options. And then once you go into the Advanced tab and choose Routing, Default Routing and Remote Access class, look for scope option number 51 down here, if I can scroll down and get to it. And 51 allows you to enter in a different lease duration. And you can enter this in. You don't have to enter it in hex. It will translate to hex. But let's say an hour, so that's 60 times 60, it's 3,600 seconds, then you'll enter this in seconds. And then I'll go ahead and apply this, and if I come back to it, I see that it's automatically converted that to a hex number for me, which is actually E10 there. So then I click OK, and then now if I go back over here to the actual address leases, and I'm just going to delete all of these for the time being. If you want to delete them, sure. Then if I restart the RRAS server over on this DC Nugget 1, then we'll see it releases those addresses with a shorter duration. So let me just OK this, and I'm going to clean up things a little bit here. And then I'm going to just go here and restart the service. So I'll go to All Tasks by right-clicking on the server and choose Restart. Once we restart, we're going to go back over to DC Nugget 2 and see how it has changed its lease duration. So that's restarted. Now I'll go to DC Nugget 2 and go back to my address leases where I refresh the screen, and now I notice that these are only 1-hour leases right now, because if I go to a command prompt and do a time, let's see, it's 10:56 right now, and so that's, of course, a 1-hour lease duration that we have. Now, another thing that's important in terms of the DHCP item there is that by default, look at this down here at the bottom, it says allow RAS to select adapter. That's the default behavior of this. So really, it's just kind of random. When you first configure RAS, it just says, oh, let's just pick this network adapter. And it's going to decide to use that to broadcast and obtain its DHCP addresses, its DNS, its WINS services, and all that for the dial-up clients. Well, if you got multiple adapters on here and it just selects one at random, it might select the wrong one. So I strongly recommend that you manually choose whichever one you really want this to apply to. In this case, for example, my private network IP address interface card is going to be the one that accepts or obtains its DHCP DNS servers. Now, if DHCP is not working out for you, either you don't use DHCP as part of the network, or you don't want to deplete any addresses out of the DHCP pool, then you could configure a static address pool, and then you just click on Add, and then you just enter in the range of addresses you want. So you might do something like this. It automatically calculates the number of addresses that will be available for you there, and then you click OK. And you can add in additional address pools here if you want. Now, in terms of troubleshooting, the key thing to keep in mind here is that you don't overlap whatever the static address pool is with any existing DHCP pools that you already have available or with any IP addresses that are already in use on the network. And one handy little thing I kind of find is if I reserve a certain portion of my address space, like I did just here, the end of the Class C address space, then anytime I look on the network and I see trouble or broadcast or something else coming from a specific IP address, I can immediately say, oh, well, that's one of my RRAS client's addresses. That's one of my VPN connections addresses. So I'll know exactly where to go to troubleshoot. Now, let me also point out here that we have an item that says Enable Broadcast Name Resolution, and that's exactly what it does. Remember, broadcasts are normally limited to a single segment, and they don't go across a hop or a router. But this is a little bit limited in the thinking when you look at the dialog box help system by clicking on the question mark and clicking on this checkbox, because it says it allows name resolution without using WINS or DNS on a single subnet LAN. That might not necessarily be true, especially if you're like a lot of RAS servers that have multiple network cards connecting to multiple different parts of your network here. So for example, here I've got a laptop dialing into the external interface on this RAS server right here, and then when it looks for a server named Server 5, this RAS server will broadcast that out of all of its connected network interface cards to each one of these various networks. Now, one thing to keep in mind, however, is that this laptop, let's say this is laptop 01, this laptop cannot broadcast for other hosts that are also VPN clients on the same external interface. So, for example, if this laptop is broadcasting for client 27, which is also a VPN or dial-up client, what's actually going to happen is that broadcast is going to go out these ports, and it's never going to find it, but it's going to go out those ports, but it doesn't double back and go back out the same external port that it came from, finding this other VPN or dial-up client. Now, on the PPP tab, just briefly, we can allow multi-link connections. And this would allow multiple, for example, ISDN lines or multiple modem dial-up connections on a single host to connect to the same RAS server. So, if I've got two 56K modems connecting, then I'll be able to double my effective bandwidth to this RAS server. And this multi-link connections checkbox simply allows a host to use two or more modems to make this connection, or two or more ISDN lines, whatever you're using. And then you can use dynamic bandwidth control using bandwidth allocation protocol or bandwidth allocation control protocol. And what this does is it allows you to also kind of intelligently configure how the connections are handled. For example, if I've got two 56K modems dialed in, and I want it to be able to back off to drop one of the connections if there's an idle period of time for, 5 minutes, then it will, using bandwidth allocation protocol, enable it to do that. And you also have to configure that through remote access policies, which we'll look at a little bit later on. Link control protocol extensions doesn't really say much to us, but basically the idea here is if you're going to use callback, and that's where you'll have, for example, a modem client dial in, and then you'll have the RAS server dial out to, back out to the number to call back that RAS client and establish the connection, then you have to have this checkbox selected, and then of course software compression will save on your bandwidth, because it'll help package up the packets in such a way that they will fit into smaller space and be more efficient in your network traffic. And then on the logging tab, you see some self-explanatory items that you can see what you want to have logged, and you can also go to additional logging for RRAS information for debugging purposes, but that's extremely verbose information, so make sure that you only do that if you really need to. And then the actual logs themselves are in the Windows tracing subdirectory. In this video, we started our introduction to routing remote access services, and this was just part one because this is a huge topic which will cover many nuggets. First of all, we looked at the RAS functions that you can use RAS for. We'd already talked about DHCP relay agent in a previous nugget. We addressed it again a little bit here. But we also see that you can use it for demand dial, for VPN connections, routing in general, all that kind of stuff. And then we use the wizard to go ahead and set it up. Now, I just did a kind of basic configuration so that I can show you how to do some of these things manually as well. And once you use that widget the first time, you can't use it again unless you first disable routing and remote access. And we look at the server properties. Those are really foundational to the functionality of the rest of routing and remote access. For example, just about everything depends upon some kind of an authentication, especially if it's something like a demand dial connection, a dial-up connection, a VPN connection, all that kind of stuff. Gotta know the differences in those authentication methods, which ones will encrypt, which ones will, do reversible encryption, all that kind of stuff. We looked at IP address allocation as well as point-to-point protocol properties, and finally we concluded with looking at logging before we move on into our next nugget, where we'll start off looking at the various ports that are created after a setup. I hope this has been informative for you, and I'd like to thank you for viewing.